Hi, my dear friends. Welcome back to another class of SQL. And in this class, I shall be discussing about the concept of transactions in SQL. Okay, transactions. So, what is a transaction in SQL? A transaction is nothing but it is a group of SQL statements which, when executed, is expected to do either everything or do nothing. Okay, so you will have a group of SQL statements. Together, that group of SQL statements, when executed, then it is expected that it will do either everything or it will do nothing. So, this group of SQL statements is known as your transaction. Okay, that's what I've written in line number 2. So it is a group of SQL statements which, when executed, operate on the principle of either do everything or do nothing. Okay. So a transaction, further I've written that it can be treated as a single unit because ultimately you will have a group of SQL statements together. When you combine them, this group of SQL statements, then they can be seen as one single unit, and that's why a transaction is also considered to be as a single unit, and where it is expected that the whole activity will be completed. That's why written here it is a single unit in order to complete the whole activity, where some sequence of tasks needs to be performed. So ultimately your transaction can be treated as a single unit where you have some group of SQL statements, and some sequence of work will be done here in order to complete the whole activity. So ultimately if you have a one big goal, and that one big goal will be solved via some sequence of work, and that sequence of work can be basically performed by those group of SQL statements, and those that group of SQL statements is treated as a single unit which is known as a transaction. So the expectation is that the whole goal will be achieved once the entire sequence of work is performed, when that group of SQL statements is executed perfectly, and that group is a unit which is known as a transaction. So that is why a transaction is known as a unit. By unit I mean it is a group of SQL statements which, when executed, operate on the principle that do everything or do nothing, and here it is expected that some sequence of work will be done in order to complete the entire activity. Okay. Now, if a very important question may arise in the interview or even in your job life also while handling transactions, how do you identify a successful transaction? How do you identify a successful transaction? Then your answer must be that a successful transaction must pass the acid test. A successful transaction must pass the acid test. That's what I've written in line number 5. Every successful transaction must pass the acid test. Okay. So a successful transaction must pass the acid test, where acid stands for, now the abbreviation full form for acid: number 1, A for atomicity; number 2, C for consistency; number 3, I for isolation; number 4, D for durability. So these are the four types of transactions which, when performed, then we can say that yes, the entire transaction, it is a successful transaction. Okay, these atomicity, consistency, isolation, durability, these are individual sub transactions, you can say, and when all these parts are satisfied, then I can say that yeah, the entire transaction is a successful transaction. That a successful transaction must pass the acid test, where A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. And when that happens, then it basically ensures that your database is always in a consistent state, and it will be always in a correct state. Okay. Now atomicity, this atomicity, atomicity transaction, it basically means that, or it basically implies that either the entire transaction must be finished or revert back the whole transaction. Okay, or revert back the entire database. So again, atomicity transaction means that either the whole transaction must be completed, otherwise revert the database back to its old state. What does it mean? For example, you have two persons. One is person X, another is person Y. Person X has, say, suppose 2000. Okay, person X suppose has $2,000. Person B suppose has $200. Okay, and it is expected that $200 will be debited from person X to person Y. Okay, so this will be a transaction where there are three steps, and all these three steps must be followed. Then only the entire transaction will be completed or finished. And if any one of the steps doesn't get followed, then revert the database back to its old state. Okay, that's what I stated for atomicity transaction, that either the entire transaction must be completed, or otherwise, or revert the database back to its old state. So suppose person X has $2,000, person B has $200, and $200 is to be debited from person X to person Y. Okay, so this will be a transaction, and in this transaction, supposedly there will be three steps, and all these three steps must be followed. Then only the entire transaction will be completed. Otherwise, revert back the database to its old state. So, what are those three steps? Like, for example, number one, uh, the person X must have a minimum balance of $200 in its account. Okay, person X must have minimum balance of $200 in its respective account. That is step one. Step two, once the money is debited from person X's account, once the money is debited from person X's account, then the balance of person X should be updated to how much? Not $2,000 minus $200, that is $1,800. Okay, that's what the balance should be updated to. Of what person? Of person X. This is the second step. And third step is, once the money is debited from X's account and credited to Y's account, then the balance of Y should be also updated. Previously, the balance of Y was how much? $200. Now it should be how much? 200 plus 200, $400. Okay, so these are the three steps. Number one, for person X must have for person X, this X person must have a minimum balance of $200 in its account. Then only $200 will be debited from its account. Number two, once the money is debited from person X's account, then the balance of person X should be updated to how much? It should be updated to $1,800. And step number three, once the money is debited from X's account and credited to Y's account, then the balance of Y should be updated to how much? Now, 200 plus 200, that is $400. Now, if all these three steps are followed, then yes, successfully the entire transaction will be finished, completed, and the money will be successfully debited from X to Y. Okay. But if suppose any one of the steps doesn't get followed, suppose step number three doesn't get followed. Steps one and two have been followed. That is, for person X, the minimum balance is $200. Checked, no problem with that. Yes, the person X has minimum balance of $200. Number two, after the money has been debited from X's account, the balance of X has been updated correctly. That is $2,000 minus $200 is $1,800, and it is reflecting the current update that yeah, the balance has been updated successfully to $1,800 of person X. But suppose step number three is not followed. That is, for person Y, the account balance has not been updated to $400. It still shows $200. In this case, all the steps are not followed. One and two are followed, but step number three is not followed. So in this case, what will happen? The $200 will be credited back to X's account, and the balance of X then should correctly update to $2,000. So in this case, the database reverts back to its old state. That is, X has got $2,000 and Y has got $200. Okay, but if all the three steps are followed, then finally X will have $1,800 and Y will have 400. Y will have $400. Okay, so that's what atomicity transaction means, that either the entire transaction must finish or revert the database back to its old state. Any one. Either the entire transaction must be completed successfully, and if it doesn't, then revert back the database to its old state. Okay. Then second is consistency. Consistency transaction, this step is also very much important because it ensures that your database is always in the correct state. That is, the data of the database is always in the correct state. For that, we apply some constraints, like for example, data integrity constraints. Okay, one data integrity constraint can be applied on, say, you have an amount column. In your transaction, you have a column known as the amount column, and the data integrity constraint on that amount column is that the amount should not exceed beyond 100,000. Okay, maximum limit is 100,000. That is a constraint, a limit. Okay, so in that way, the debit credit can be easily controlled of a particular account for with respect to the money. Then your third step is isolation. This is also a type of transaction. What it does is that it is very much helpful in case of concurrent executions. Like, say, for example, it this isolation transaction ensures that there will be a concurrency control. It will ensure that there will be a concurrency control in case of concurrent executions. Now, what does it mean? Suppose you have an account where the balance is $2,000, and you have two persons, X and Y, who are trying to withdraw money from it. Okay, suppose X is trying to withdraw, $1,800, and Y is trying to withdraw $300, for example. Now, what if X and Y, both of them, are allowed to, withdraw money from that common account at the same time? What will happen if X and Y, both of them, are allowed to, withdraw money from that common account at the same time? Then will it be possible? That is a concurrent execution. X goes for $1,800, Y goes for $300. So 1,800 plus 300 is $2,100. But what is the total balance of that common account? It is $2,000. So, if both of them are allowed to withdraw their respective amount from the same account at the same time, then will it make any sense? Because the total balance has to be 2,100, but the total balance is 2,000. Total balance must be $2,100 in that common account, but regretfully, the total balance in that account is $2,000. So if both of them are allowed to, go for the withdrawal, then that won't make any sense. It will create problem. So that is why here isolation steps in, where it will ensure that there is concurrency control in case of concurrent execution. This is a concurrent execution. Okay, the problem that I stated about. So here a concurrency control will be applied, like anyone will be allowed to withdraw money from that particular common account. Anyone, say, Y is allowed. Y is allowed to withdraw money from that common account, and Y withdraws the money of, $300. So what will be the remainder in that account? It will be $1,700. So now X will be allowed, and yeah, X might have to do some adjustment. This is just a simple case scenario that I stated, that isolation steps in whenever there is some issue of concurrent executions. Then it will ensure that there is concurrency control in case of concurrent executions. Okay, here we had the issue of concurrent executions, and that's how the problem can be solved, that either one will be allowed to withdraw the money from that common account, not at the same time. Okay, and the last one is your durability. Well, durability step or durability transaction, it basically ensures that once a transaction is committed, then your data that data will be stored in a non-volatile memory, or in some storage, in order to ensure that the data does not get lost. Suppose anything bad happens, any crash happens, or anything bad happens with the database, then in that scenario, the data should be saved. It should not get corrupted, it should not get lost. That's what this steps ensures. That's what this step durability ensures. Okay, so if all these steps are followed, then we say that yeah, your transaction, it has passed the acid test, combining all these four steps, that is, atomicity, consistency, isolation, and durability. Okay, and before we jump into transaction further, we must follow these steps. That is, what is the format? Like, first of all, if you want to start up with a transaction, then you must write this command, begin transaction. Begin transaction will simply instruct to the SQL that yeah, transaction has begun. Okay, Then you have a rollback transaction. Rollback transaction is just like your control Z operation, undo operation. Whatever I did, that can be undone via the rollback transaction. Then third one is your commit transaction. Commit transaction is like that, once you commit a transaction, then whatever you did, that cannot be undone. Okay, rollback transaction was what? Rollback transaction is like, whatever you have done, that can be undone also. It's just like your control plus Z operation, undo operation. But once you commit a transaction, then you cannot roll back. That is, then you cannot go for control plus Z. Then you cannot go for undo. Okay, control plus Z or undo can be done by rollback transaction only in SQL. But once you commit a transaction, then you cannot roll back. Then you cannot roll back. No control Z, no undo operation. Okay, done is done. Once committed, it is committed. And last is save transaction. Transaction is used to create save points. This transaction is used to create save points between multiple queries under a transaction. Okay, its application we have to understand. For that, I have created a code. From there, we can understand that. We will go through. So, regarding the transaction problems, we shall dive in. We shall create. I shall create a new class for that. The next class where I will explain you the problems. How can problems be solved via transactions? So that's it for this class. That's it for this class. If you have liked this class, then please hit the like, share, and subscribe button, and hit the bell icon for further notifications. So thank you.